Hello and welcome to the very first video of the JUnit tutorial series. So in this tutorial series, we'll be learning JUnit. We'll be seeing what is JUnit and what are the other components of the JUnit, and we'll try to learn JUnit completely. So it is a crash course type of course. So let's get started. So in our very first video, we'll be seeing introduction to the JUnit, what is JUnit and why it is important, why to use JUnit. Okay, so let's get started. uh, JUnit is a unit testing framework for Java, and the current version of the JUnit is JUnit 5, which is the latest version. And the framework is used by the Java developers to write and execute the test cases. Okay, so there are different types of test cases. Okay, so the JUnit is specifically used for the unit testing, refers to the testing which refers to the testing of small chunks of codes. Okay, so it is basically done by the developer itself. So very small chunk of code is used, and the test cases are written for that code, and the Java developer will execute those test cases, right? So it helps in early identification of the defects. Okay, so as I said you, the unit testing is done on the very small chunk of the code. So you can do unit testing on that small chunk of the code, and you can, if there is any defect in the code, you can get and rectify that error there itself. Early identification of the error is done using JUnit. Okay, so every time a new code is added, all the test cases have to be re-executed. Okay, so in JUnit, you are performing the test on the small chunk of code. Okay, so every time you added a new piece of code, you have to execute all the test cases again. Okay, so it is an open source testing framework for Java programmers. The Java programmer can create the test cases and test his or her own code. Okay, so as I told you, unit testing is done by the developer itself, because it is done on the very small chunk of code which is written by the developer itself. Okay, so let's go ahead and see what are the types of unit testing. Okay, so there are mainly two types of unit testing. One is manual testing and one is automated testing. Okay, so what is manual testing? If you execute the test cases manually without any tool support, it is known as the manual testing. Okay, it is time consuming and less reliable. Okay, so assume manual testing as if you have written a small chunk of code and you have developed your own test cases. Let's suppose 5 to 10 test cases, and you are testing those test cases manually by yourself. Okay, so it would take a much amount of time, and it is less reliable also, because you have to do everything. You have to write the code, you have to write the test cases, and you have to test those test cases, right? And the second comes automated testings. If you execute the test cases by a tool support, it is known as a automated testing, which is fast and more reliable. Okay, so there are certain tool available in the market which you can use to do this unit testing. We will see in our upcoming videos how we can do the automated testing and the manual testing as well. Okay, so the developers are tend to spend more time on reading the code. Okay, so the unit testing means you are performing the testing on a small chunk of code. That means the developer have to spend more and more time reading and improving that small amount of code. Okay, the successful code increases the confidence of the developer. Okay, so and it is more reliable and readable code is written by the developers. Okay, so if there are no errors in the code, and then the developer are tend to write the more readable and more readable code, which can be easily understand by the other developers as well. Okay, so this is the introduction about the JUnit. I hope you got the idea, some basic idea what is JUnit. So in our previous video we have seen the introduction part of the JUnit, and now in this video we will be seeing how we can set up a JUnit environment on our Windows 11. Okay, so before starting this video, there are some prerequisite softwares that you need to install in your PC in order to set up the JUnit environment on your Windows 11, right? So those two softwares are Java and Java JDK that you need to install in your PC. So to install these two, quickly I will show you how you can install these two softwares in your PC. Just go in your Chrome and open up the new tab and write uh, download Java. Okay, so for very first website will come, which is www.java.com, and you will go there at download page, and you can see a little button over here, download Java, and you can download Java from here. And to download the JDK, again you open up the new tab and write download JDK. Okay, so very first page come from Oracle itself, which are the developer of the Java. Okay, so you just scroll down here, and according to your operating system, you select your operating system, and just select your version, X 64-bit or 34-bit. You can download it, click here, and the download will start. I will not download it again, as I have downloaded and installed. Okay, so these are the two softwares that you need to install in your PC. Once you install these two softwares, and then we can go ahead and set up the JUnit environment in our Windows 11. Okay, so to do this, there are two ways by which we can do this. One is manual way, you have to download those jar files of the JUnit 4 manually from the internet, and you have to place those two jar files in your build system of the project. Okay, and the second one is using an IDE. So in our today's date, there are IDEs like IntelliJ IDEA and Eclipse. Those are pretty smart and advanced one. You don't have to download the jar file manually. You just write one line import statement of that JUnit, and it will automatically detects that you want to include the JUnit dependencies in your project, and it will automatically suggest that you should download these JUnit dependencies in your project. And if you just click on that download, it will automatically download and add those jar files in your build system. Okay, so we'll see both the ways. One is manual and one is automated way. Automated we'll be seeing using IntelliJ IDE, because this IDE is preferred by most of the developers in today's world. Okay. Okay, so let's get started, and let me just open my IDE first, IntelliJ IDEA. Okay, once I open my IDE, I will just go here and click on file. Wait, let it open. I click on file, new, and project. Okay, once I click here, you can see language should be Java and build system should be IntelliJ, and I will name my project as demo JUnit. Okay, and I will create my project. Okay, this window I want to create. Okay, and now, okay, so now my project has been successfully built. Okay, so we'll first see the manual way how to install. Okay, so for installation in a manual way, you just go in your Chrome and head over to the new tab and write JUnit. Just write JUnit. Just ignore my typo. So you just go here and to the JUnit 5, which is the latest version. In this video we'll be using JUnit 4. Okay, and once you head over to this site, you can see a download and install button over here. Just click on that button. You will get redirected to the official JUnit 4 repo of the repo on GitHub. Okay, and here you can see download the following jars and add them to your test class path. Okay, so they have given the link to download these jar files. We just need to download these two jar files and add it over to the external libraries that we are going to use in our project. Okay, so this is our class path. So let me just click on this junit.jar. You will get redirected to this Sonatype website, and you just click on this one, JUnit. Let it get low, and you can see here let me go into versions. Yeah, versions, you can see there are different versions they have given over here. I will select the latest one, and I will click on the browse, and you can see JUnit 4.13.2.jar. Just click on this and the jar file will get downloaded. Okay, so once this file is getting downloaded, I will just go back and I will again download this hamcrest core.jar file. It will redirect me to this, and I will click on the download, and I want the jar file. Okay, so these two files are getting downloaded. Now for the manual way, you just need to get these two jar files, and you have to paste it down over here inside your external library, that is a class path for your project, right? So this is the first way, the manual way, that you can do it. And for the second way, using the IntelliJ IDEA itself, okay, so you don't need to do anything. You just go ahead and create a new Java class. Let me call it as test here, because I will write the test cases over here itself. And just let me create my main method over here at also main method. Okay, and I will create one custom method over here, a public static, not public, void test cases, and I will write this method, and I will write system.out.println executing JUnit test cases. Okay, so after that I will just come here or come over here, and I will just simply write at test. Okay, as soon as I write this, you should get error telling that okay, and you can see you are getting one little error over here. You just click on this button, and as you can see, it is suggesting you that you should add JUnit 4 to your class path. Okay, so as soon as I click over here and click OK, it will automatically add JUnit dependencies to my class path, and it will also import the JUnit.test class from the JUnit library itself. Okay, and when I click on the external libraries, you can see JUnit dependencies is getting added, and exactly the similar two files that we are downloaded from the web, those two files are also getting automatically added to this external libraries folder. Okay, so this is how you can add those dependencies of the JUnit in IntelliJ IDEA without downloading manually downloading any files. And as soon as I click on this run test cases, the test cases should run successfully. I should get prompt of successful testing. Okay, so you can see green tick, which is represents as test cases passed, and one little line I have written inside this method executing JUnit test cases, that is printing on over here as well. Okay, so that means everything is working fine. Our JUnit dependencies is also getting added inside our IntelliJ IDEA. And now in this video we'll seeing how we can set up and configure a JUnit to in our project. Okay, so we are adding or installing the JUnit into our project, and for this video you have to the prerequisite for this video is you have to understand the Maven first. So if you have a good understanding of Maven, then you can continue this video. If you don't have any background knowledge about Maven, then you can go ahead in our channel, and we have also one series on Maven. You can watch that series. Because you have to understand what is pom.xml file, how Maven works, how the dependencies are handled in Maven project, because we're gonna set up the JUnit and configure the JUnit in our Maven project. Okay, so I am assuming that you have a good understanding of Maven, what is Maven and what is pom.xml. Okay, and then you can go ahead and watch this video. Okay, so let me just open my IntelliJ IDEA. Okay, by the time it's opening, do like this video and subscribe to our channel. It helps us a lot. Okay, I will just click on file, new project. I'm gonna create a new project. I will write give the project name as JUnit for Maven. Okay, any name you can give over here. Okay, so the language should be Java and the build system should be Maven. In this case I am using Maven build system. In our previous video we have used IntelliJ build system, And now for this video we'll be using Maven build system. Okay, so the JDK I'm using 19, which is the latest one, and I'm just gonna say create. Okay, this window, it will create it will build and create my project. Okay, so and let it get built. Okay, so now my project is built successfully. Now you can see, since this is a Maven project, you can see source, main, Java, and resources files are there, and test files are also there. Okay, so inside, first we need to add the dependencies of the JUnit in order to use the JUnit in our Maven project. So how we add the dependencies inside a Maven project? Yes, by using the pom.xml file. So we go inside our pom.xml files. Since this is a new project, there should not be any dependencies tag over there. So we will add our dependencies. We will write dependencies tag, and inside dependencies tag we will add our first dependency tag. Okay, so artifact ID should be JUnit, and the group ID should also be JUnit. Okay, and the version we will be using the latest one, and the scope should be test, because the JUnit is used for the testing purpose only. So we will assign the scope as test only. Okay, so and now we have added the JUnit dependencies with the latest version, and the scope should be test. Now we can go ahead and write the test cases for our this project. Okay, so before writing these test cases, as you might recall, once we add the dependencies, or once we do any kind of update in our pom.xml file, we need to rebuild our project, Maven project. Okay, so for doing do this, there are two ways, but you just click over here, load Maven changes, and there is also shortcut Control Shift O. You can also press that shortcut as well, or you can click on this button as well. Or another way of doing this, you just go inside this Maven tab, you just click on this download source and other documentation, and you just go ahead and click reload all Maven projects. Okay, so I'm just gonna go with this little button over here, load Maven changes. It will automatically download the JUnit dependencies, and you can see once you go into external libraries, the Maven JUnit dependency is getting added over here. Okay, so now my JUnit is successfully added inside my project. Now I can go and create my new Java class. I will name it as test here, and inside this I'm just gonna create a new method, public void test. And okay, and now uh, in order to tell the my project that this is the JUnit test cases method, I'm just gonna give the annotation as add test. And as soon as I write add test, the IntelliJ IDE identifies that this is the JUnit method that is used to uh, process the test cases, run the test cases. It will automatically import the org.junit.test import statement, and you can see our this method is ready to test. Okay, so don't worry if you don't understand this add test. These are the annotations. We'll be looking all the annotations, or the important annotations which are used in the JUnit in our upcoming videos, so stay tuned for this. Okay, and as soon as I click on this run button, little run button over here, my test cases should be run. Okay, so since there are no test cases defined in this, the green tick should be there. Yes, all the test cases passed, test case pass 1, and process finished with exit code 0. Okay, so this is how you can use Maven as your build system, and you can add the dependencies of the JUnit inside your pom.xml file, and you can use the JUnit in your Java project, and you can define all your test cases over here, and you can test those test cases with the Java code that you have written over here. Okay. So in this particular video, we will be writing our first JUnit test case, and it will be, this video should be, it will be a step-by-step guide to write a simple JUnit test cases. Okay, so let's get started. I will open my IntelliJ IDEA and I will click on file, a new, I will create a new project. Okay, I will create my project name as first test case. Let me give it a name as first test case, and the build system should be Maven and the language should be Java. Okay, so let me go ahead and create and give this window. Okay, it will create my empty Maven project, and now I will go ahead and create the dependencies. And I hope you have watched our previous video as well and you're following this tutorial series and you're getting what I'm doing over here. Okay, I will add my JUnit dependencies over here and let me get my latest version, and the test should be scope because the JUnit is used for the testing purpose, right? Okay, so I will go and inside my src main, and I will create a new Java file inside my op.example, and let me write the code in my main class itself. Okay, the class which is given by default by the Maven build system. Okay, and I will go ahead and write the code inside this itself. Okay, so let me just or else I can create a new Java class, and let me call my Java class as movies. Okay, so this is inside my package of.example, and I have created one public class which is named as movies. Okay, and I will create one new method inside this which is public, and this method will return the list of the movies. So the return type should be list, and which is of type string. Okay, and let me call okay, so IntelliJ IDEA is telling me that you should import the list. Let me call import from the util package. Okay, and let me call my method name as get movies. Get movies is my method name. Okay, and I will just go ahead and okay, and I will just go ahead and return the empty list collections from the collection package. Collections dot empty list, collections dot empty list. Okay, collections dot empty list is the method inside the collection. Okay, so I do not require this import statement over here. And okay, so this is my method. This method will return the movies in the format of list, which is of type string. Okay, so to test this method, I will go inside my test folder, and which is there is a Java, and I will create a new Java class. Let me call it as movie specs, because a lot of developers follow this convention of naming the spec before the class that you are testing. Okay, I will follow that convention over here, and inside here I want to test my movies.java method, which is get movies. So for testing purpose, as we know, we have to give assertion as test, and after that I will just create one method public void, and I will name the method as movies em empty, movies empty or not. Okay, so we are checking whether the movie is empty or not. You can give your method name whatever you want. There are no restrictions on that, but give the meaningful name that you can understand what this method is going to do. Okay, so there are three steps for the testing one piece of code that you have written inside your Java class over here. So so the three steps are, one, first one is arrange. Arrange meaning that arrange in the sense you have to set up your data. Okay, I will give the comment as set up the data. And the second step comes act. Okay, so what is act? Act means call the methods. Okay, so we are going to call the method that we have written over there. Okay, and third step is assert. Okay, so assert means what are the uh, evaluation that we have done on that test cases. Okay, so we're gonna write evaluation of the condition. Okay, so what are the condition that we are going to get? Evaluation of the conditions. Okay. Okay, so these are the three steps that we're gonna perform on our get method, get movies method. Okay, so first of all, arrange or the set up the data. Okay, so I will just gonna create a object of the movies. Okay, or let me call it as movies, and which is equals to the new movies. Okay, I will create the object, and since this method doesn't require any parameter to be passed, so that is pretty much data that we have to set up. Okay, so now we go ahead and act, that is call the method. Okay, so we're gonna call this method. We will write movies dot get movies. Okay, and since this method return a list of strings, so we have to store that in over here as well. So we will write a list of type string, which let me call it as list itself. Okay, so we're gonna hold that entire list in this list method object. Okay, okay, so we have called this list, and now we have to check out the evaluation of the conditions, right? So for evaluation we have assert true, we have assert true. Okay, and inside this we're gonna pass list dot is empty. We're gonna check whether the list is empty, and second parameter we will pass a java 8 lambda expressions, which is this. We're gonna pass the lambda expression, and we're gonna say movies should be, oops, sorry for the typo, movies should be empty, movie should be empty. Okay, and yeah, end this. Okay, so we are getting error. So import. Okay, so java.JUnit assert true, import that. Okay, okay, so I guess I have imported the wrong one. Let me get back and import the right assert. Okay, assert statement. Okay, okay, so again I'm getting error. Why I can't? Okay, fine, just wait a minute. Okay, so we're gonna import, I guess, this one, not the JUnit one. We're gonna import that of .JUnit, and we're gonna clear this out. Okay, so this is assert to whether the list is empty. So in our case we are returning the empty list. Okay, so this empty list will be stored inside this list variable, and this value will be evaluated as true, and our test cases will get passed. Okay, so let's go ahead and see whether our test cases get passed or not. Okay, so I'm just gonna go here and say run specs, movie specs, and it should give me a red, sorry, the green tick. Okay, so here you can see green tick. The all the test cases that you have written inside this method, movies empty or not, are getting evaluated as true. Okay, so now one thing I can do is what I can do is instead of calling the assert true, I can call assert false as well, assert false. And now if I just save, and I will just again call my movie specs, and now this time I should get the test cases as failed, because here you can see we are checking whether the list is empty, and yes, it is returning the empty list, but we are checking it on assert false, which is this one evaluated as true, and we are checking it on the false, and our test cases should get failed. Okay, And one more thing you can do is you can just state as assert true, but you can, what you can do is you can come over here and instead of passing that empty list, you can just pass null. Okay, you can return the null over here, and you can just go ahead and run the movie specs again. In that case also you should get the test cases as failed, because the list is null and it is returning the null, and we are checking whether the list is empty or not. Because okay, and now I will just revert back to what I have done earlier, and so that my test cases should get past. Okay, this is our past. Okay, so in this video we will be seeing assertion methods in JUnit, and how to use the JUnit's built-in assertion methods to test your code. Okay, so let's first understand what are the assertion methods. So assertions are the utility methods to support asserting conditions in the test. So these methods are accessible through the assert class in JUnit 4 and the assertions class in JUnit 5. Okay, so we have two versions of the JUnit 4 and JUnit 5. So for using, if you are using the JUnit 4, then you can use the assert class, and if you are using the JUnit 5, then you can use the assertions class. Okay, so you could have asked why to use the assertion class. Okay, why to use the assertion methods that we are getting from the JUnit. Okay, so first let's understand why we are writing the test cases. Okay, so we are writing the test cases to check whether our test cases that we are written are getting pass and fail. If it is getting failed, then we have to rectify the errors, and we have to uh, check our code, and we have to debug our code. Okay, so the way we are doing is we are executing the code that we want to test. Okay, and then we are verifying the result is what you expect. Okay, so there are two variables. One is expected result and one is actual result. Okay, so if your actual result is equals to the expected result, then the test cases is passed. Okay, if the both are different, then your test cases would have failed. Okay, so there are many assertion methods that JUnit gives us. Okay, so these are the list of the all the assertion methods. Assert equals is there to check the equality. Okay, we'll see how we can implement this method each in our code. But first let understand uh, them theoretically. Okay, so at assert not equals to check the inequality, and assert array equals to check if the given two given arrays are equal or not. Okay, assert iterable equals to check if the two given iterables are equal or not. Iterables can be anything. Okay, array list or list of anything. Okay, assert not equal if object is not equal. Assert true, it checks whether the value is true, and assert false, it checks whether the value is false. Okay, and these are the three different all assert methods. Okay, so let's go ahead in our IntelliJ IDEA and create our new project to understand the assert methods that we are just seen. Okay, I will name my method as assert methods. Okay, I will name my project as assert methods, and I'm using the build system of Maven because it is easy to use and easy to understand, and all the dependencies are handled by Maven itself. I don't have to worry about the dependencies. I just need to go ahead over here and I have to add the dependencies tag for my JUnit. That's it I have to do, and rest of the thing will be handled by uh, this Maven. Okay, I just want to say JUnit. Okay, JUnit, and here also I'm giving JUnit, and version should be latest one 4.3.0. Okay, and the scope should be test. Okay, as soon as I did this, I have added the dependency. I have to reload my Maven project just by clicking over here. My Maven project got reloaded. Okay, so for this let me just go ahead and create a new Java class. Okay, I'm just gonna say I'm gonna create a new Java class, and I'm gonna name my class as calculator. Okay, and inside this class I'm gonna create one method which is public, and it is returning the integer, and I will call my name method name as add, and it is accepting two parameters, integer a and integer b, and, and it is returning me the summation of those two numbers, two variables a and b. Okay, so this is my pretty simple calculator class which has one method add, and I have to test this add method inside my using the JUnit. Okay, and I have to implement all those assertion methods as well. Okay, so let me go ahead inside the test folder, and inside Java folder I'm just gonna create a new Java class, and I will call it as calculator specs. Okay, and over here let me just first what we'll be doing, we will check, or we will understand assert equals methods. Okay, so for that let me just go ahead and create annotation as add test, and it as soon as I add this okay, why should it test, and after that what we can do is we can use another annotation as a display name. It is very useful when you have multiple methods to test, then in that case you can see which one got. Okay, okay, so I guess this display name is there inside the JUnit 5.8, so we have to use the JUnit 5. So just click on this add JUnit 5 to class path. The IntelliJ IDE will handle the rest of the thing and add the JUnit 5 dependency to your project, and then in that case we have to give one message, and we are giving message as assert equal test case. Okay, so this is assert equal test case. Okay, and now I just have to create those methods. Okay, so my method is public void, and let me call my name as assert equal test, assert equal test. Okay, so this is my assert equal test method, and inside this I'm gonna implement the assert equal method. Okay, so over here what I can do is I will use the assertions class, because as I have told you, if you are using the JUnit 5 you have assertions class, and if you are using the JUnit 4 you have assert class. So since we are using JUnit 5 we have to use the assertions class. Assertions dot, as soon as I write dot it will give me all the supported methods that are there inside the assertions class. Okay, so we are seeing assert equals, so we will write assert equals, and you can see I have to pass uh, the parameters as the expected and the actual output. So my expected output is 4, and my actual output I will get it from okay, so before that we need to some access this add method somehow inside the calculator specs method. Okay, so for that I'm just going to create the object of this calculator class, calculator calc. Let me call object name as calc, new calculator, and over here using this calc object I'm just gonna call that add method, and I will be passing 2 comma 2 as the input to this method, and that's it. That or you can see the expected output is 4, and the input that we are going to passing is 2 and 2 comma 2, and the call will be given to this method, and this method will return 2 plus 2, that is 4, and over here you can see the expected output is 4 and the output that is given by our method is also 4, then in that case this test case should pass. Okay, so let me just go ahead and run this test case. Okay, yeah, you can see test case passed 1, everything is green, so we can see that assert equal test, uh, it is getting passed. Okay, so if you want to get see how the test case fail, just give the another output. So here you can see 6 plus 2 is 8 and the expected output is 4 and you are getting the output as 8, then in that case this test case should get failed. Okay, so let me just run this. Okay, okay, so here you can see the test case fails, the test case failed 1 and you can see expected is 4 but was 8. Okay, so the assert equal is expecting the output as 4 but it is getting the output as 8. Okay, so let me just revert back to what I did first. Okay, and now in that case there is one more method, there is one more parameter that you can pass to this assert equals method, uh, but this method parameter is only works if you are using the JUnit 5, right? So if you are using the JUnit 5, then you can, what you can do is you can use the Java 8 lambda expressions to give a message to this assert equal methods. Okay, so if I would say that uh, both are not equals. Okay, and let me just go ahead and call this. Okay, so you can see assert equal test is getting passed, but as soon as I give 6 over here and I will again run this calculator specs and you can see uh, it is printing that both are not equals, expected 4 but was found 8. Okay, so this is the very good feature of the JUnit 5, that you can pass one lambda expression over here and you can send one message to this method, that whatever method that you want to print over here, but this method is only getting printed on the test cases failed message only when if your test cases if is getting failed. Okay, so if your test case gets failed, then in that case this method this message will pass on the console. Okay, printed on the console. Okay, so you can see our test cases is getting failed and that's why we are getting the both are not equals, expected is 4 but was found 8. But if we give the correct or the input which passes our test cases, then in that case we should not see this both are equal, both are not equals. Okay, so you can see if you are, we are not getting any message over here. Okay, so this is a very good feature of this JUnit 5 that you can use. Okay, so there is one more method, that is assert not equals, which you can use assertion. Okay, assertions dot no assert not equals, and we can pass is 3. Let me pass it as 3 and I will call calc dot add 2 comma 2 2 comma 2. Okay, and let me just comment this out. Okay, so let's just run this. If we run this, you can see test cases is getting passed. What assert not equals will do is it will compare this parameter with the parameter that we are getting over here. This method will return 4 over here and unexpected is 3. Okay, so if the result that we are getting from the method is 3, then in that case this test cases should fail. Okay, so let me give input such that I will give get the result as 3, and if I run this again the test case should get failed. Okay, see the test case is failed. Okay, so this is how assert not equals works. Okay, so let me just comment this out and just let me run this again, so everything is getting green ticked. Okay, so this is how we can use the assert equal test, and now we can now we will see one example of assert array equal test case. Okay, so just let me copy this out because I need this over here, and I will just name assert array equals test case. Okay, so this is array equals test case. So let me just call it as public void assert array equals, this is my method name, and over here inside this I will call my assertions dot assert array equals. So what it takes input as to array. So let me just pass the to array over here itself, int 1 comma 2 comma 3, and I will pass another input as new integer array. We call it as 1 comma 2 comma 3. So what it will do is it will compare this one array with this another array, and if both the arrays are true, the test cases will be evaluated as true. Okay, so let's just go ahead and test this out. Okay, so here you can see we have assert equal test, which is passed because both are commented out, so it will get passed, and assert array equals method is also getting passed because both the array elements are the same. So if you want to see how it fails, let me just go ahead and jump all those integer values from this array, and if we go ahead and again we run this, and if we run this you can see our one test cases is getting failed. You can see at index 1 expected is 2 but was 3, because at index here you can see here expected is 3 but it was 2. Our test case will get failed. Okay, so this is the assert array equals method that we have. Okay, so next we can see assert not null. Okay, assert not null, we will see assert not null one. Okay, so we'll just copy this out and just paste it over here. Assert not null test case, not null test case, assert not null test case. So we will write what we'll be doing is we will write public void assert not equal. This is the test case for the assert not equal that we are writing. Okay, and now inside this method let me give two strings, which is first one is null string, which value as null, and second string will be not null, which value is, let me call it as abc, which has some value. Okay, and now using the assertion start this method not null assert not null, this is the method, and I'm gonna pass the first, I'm gonna pass the string that contains the null, that is this null string. I'm just pass that null string over here, and let me just only call this assert not equal method. Okay, so you can see it is failing because since this null string is holding the null value, and our method assert not null is checking whether this given string is not null. Since it is a string which is null, then our test cases will fail, and if we give any string that is not null, then in that case our test case should get passed. Yeah, you can see our test case is getting passed. Okay, so what one more method we will see. Okay, so true. Okay, we can see over here, we will just copy this out, and I'm just gonna paste this. Okay, so we're gonna test assert true test case. Okay, and over here I'm just gonna write public void assert true test case, Okay, I'm just gonna inside this. I'm gonna create one boolean variable, which is first one is true variable, which is holding the value as true, and second one is boolean false var, which is holding the value as false. Okay, and I'm gonna say assertions. Oops, sorry. Assertions dot assert true, and I will pass the true var over here, and I'm just gonna check this assert true test. This our test cases is getting passed because what assert true is checking that whatever you have passed over here should contain the value as true, because it is checking on the boolean conditions. Now if I replace it with false var, okay, and now my test case should get failed because the value that I have passed is false, and it is checking whether the value is true or not, and it should get, you can see, expected is true, but it is getting us false. Okay, so let me just replace it with true condition. Okay, similarly assert false is there, which will check whether the condition or the boolean conditions that you are giving to this assert false method is for returning as false or not. Okay, if it is returning false, the test cases will get evaluated as true, and if it is getting true, then the test cases will get failed. Okay, so these are some methods that assertion class will provide if you are using the JUnit 5, and assert classes provide if you are using JUnit 4. Okay, so these are very good methods that we can use to test our piece of code. So in our previous video we have discussed about what are assertion in JUnit, and now in this video we will be talking about test suites in JUnit. So what is test suites? Test suite is nothing but how to group and run a multiple test cases using JUnit test suites. Okay, so the JUnit test suites allows you, or the provides you the ability to run multiple test cases at single place, or on a single click. Okay, so so imagine if you are having multiple test cases files, and you want to run them at once, one click at once, and you want to check whether all the test cases are passing or not. Okay, so in that case you can use test suites in JUnit. So we'll be seeing one example, and let's go inside our IDE and create our new project. Okay, so I will create my new project. I will name it as test suites in JUnit. Okay, sorry, JUnit. Okay, so the language should be Java, and the build system is Maven, because the dependency management is great in Maven, right? So we'll click on okay. I guess white spaces are not allowed. Okay, so we will name our project as underscore. Okay, and then we can create our project. Okay, this window. Okay, so my Maven project is created and built. Okay, now I want to, in order to use the JUnit, I have to add the dependency for the JUnit in my pom.xml file. Okay, so I will go ahead and add the dependency over here. So to add the dependencies, the main drag is dependencies, under which a single dependency tag will become, and the artifact ID. Now if you want to use the JUnit 4, then in that case you just need to write JUnit. That's it. That is the dependency, the first dependency to use the JUnit 4. And now if you want to use the JUnit 5, which is the latest version and have some great upgrades, then in that case you have to write JUnit JUnit slash we have to write like this: Jupyter, JUnit Jupyter, and org.junit.jupyter is the group ID. The version you can select any, but I will be writing release or else I will go with the latest version itself. Oh, wait a minute, I guess. Okay, so I will go with the release. RELEASE release, and scope is test. Okay, so okay, so I just need to run this so that my dependency is getting added inside. Okay, now you can see error is gone, dependency is added, JUnit 5 is added inside my project. So now I will just go here and inside my main Java file, uh, or in my main, I will just create a new Java class name as I will call it as calculator, which we have also seen in our previous video, calculator. Okay, and inside this calculator class, let me just create one test case. No, not test case. Here I have to write that method which uh, I will be testing. Okay, so I will write public, so my method should return a summation. That's why the return type should be int. Okay, so my method name is add. Okay, and this method, it will take the two parameters. One is this and one is b, and this method will return summation of those two numbers, that is a plus b. Okay, and now since we are learning the suits in JUnit, now I will create another class. Okay, so that multiple test cases should be there within the multiple classes of the Java. So I will create one more class. I will name it as something name as greetings, maybe greetings. Okay, this is my class name, and inside this class I will just create one class that is to greet the user, right? So I will just write my class name, method name as public. So this will return a string. Okay, and the method name should be greet. Okay, and oops, sorry, the method name is greet, and inside this method it will return the string hello. Okay, so this is what this method is returning. So to test these two classes, calculator and Java, I need to create two classes for the testing purpose. I will just go ahead and here I will create a new Java class. So this is our testing class, so I will write calculator test. So this is a calculator test class, and I need to create another class for testing the greeting class. Okay, so greetings test. So this is our greeting test class. Okay, so now inside the calculator test class, I need to create a test case. Okay, so to create a test case, we know what is the this at test we have to write, and after that we need to declare our method, that is public void. Okay, so let me call it a check add, maybe. And okay, so now here what I can do is this method should accept the two parameters that we are passing. Okay, so here this method is accepting the two parameters that we are passing to this, right? So here I guess we have to call that method inside this method. Okay, so here we have create the object of that class. Let me call it as calc new calculator. Okay, and so now I can access that method which is inside this calculator class, that is the add method, using this object, right? So what I will be doing is I will use assertions class assert equals method. Yeah, and all this method we have discussed in our previous video. So if you have not watched that video, go and watch that video so that you can understand what is this assertion and what is assert equals, right? So inside this I will pass the expected output. So since I will be passing 2 comma 2, so the expected output should be 4, and I will expected, and the actual output will be calc dot add. I will pass 2 comma 2 comma 2. Okay, and okay, so this is our test case for the calculator class, and now we can go ahead and create one more test case for the greeting. Okay, so we will write at test. Okay, so public void public void uh, test greet. Maybe you can name whatever you want, but give the name so that you can understand what that method is doing, right? So over here what I can do is I can again use the assertions class assert equals, and the expected output should be hello because that string or the method is returning a string hello, and the actual output that we are getting from the method is we have to create an object of that class so that we can access the method that is written inside that class, right? So we will write new greetings, and we can call that method over here using that object, right? So greet. Let me check. Greet is a method. Yes, greet is a method, so we are accessing that. Okay, and now we have two classes: calculator class which has add method, and the greeting class which has greet method. And calculator test class is testing the method that we have written inside the calculator, and greeting test class is has one method which is testing this greet method which is there inside the greeting class. Okay, so now we have two classes which have two test cases. Okay, so both are different. So now we want to run these two test cases at which are there inside the two different Java files at one time at one single click. So here comes the test suites. So for this purpose we have to create one more Java class file. So I will give the class name as test all, maybe because we are testing all the test cases. Okay, so over here what I can do is uh, I need to over here what we will be doing is we have to use one at run with run with okay, run with, and this is suit suite suite dot class. Okay, and over here so we have to do all this stuff outside the class because we are using we will call those methods or the tests inside this class, so we will write all this stuff over here. Okay, so we are getting errors, we have to implement that. We will see at suit classes. And now one second, I guess. Okay, so JUnit 4 contains this run with class, so we need to add the dependency of that one as well. and now we can use this suit classes, and over here you have to pass those class names that we have that contains that test cases, right? So our test cases are inside calculator test and greeting test. Now we have to mention those class name over here. Okay, so we will write calculator test dot class and greeting test dot class, greeting test dot class. Okay, so these are the two classes that are involved, and over here what we can do is just we need to run this test on class. Okay, so build is happening. Wait for a minute. So you can see we are getting error because what is error? Invalid test class, calculator test dot class. So wait a minute, I guess. Just wait a minute. Yeah, I think we have to. Now what we can do is run this. Okay guys, just wait 1 minute. I will rectify this error. Okay, so the error that we are getting is because of this, because over here if you look inside the pom.xml, we have first added the JUnit 5 dependency, and we have decided to use JUnit 5, but later on we have seen that run with and suit classes are there inside the Jupyter 4, and that's why we have imported the Jupyter 4. But when we are writing our test cases, we have used the add test annotation which is there inside the Jupyter 5, and we are using this Jupyter 4 classes over here, and we are using the Jupyter 5 test annotation for declaring our test cases. So that creates a conflict, and that's why we are getting error. So that error you can solve using this just import statement of the JUnit 4, and over here also you have to just replace it with the JUnit 4 import statement, so that our this class knows that all the test cases that are written over here are there written inside JUnit 4. Okay, so we will just click on run with, and you can see calculator test class has check add which gets test cases pass, and test grid also get test cases pass. So if you want to check whether if one test case is failed, how it looks like, so I will just give this test grid a failing purpose. Okay, so we can see over here, yeah, grading test is getting failed because expected is hell and we are getting hello. Okay, so this is how you can use test suits in JUnit, so that you can run the multiple test cases. So in this video we'll be focusing on how we can write the parameterized tests in JUnit, right? So till now what we have seen how we can write our test cases, what are the test suits, and what are these assertion methods, right? So now in this video we'll be seeing how we can create a parameterized test cases, right? So the parameterized test cases means we are passing the values or the test different values to that method or the test case, and the test cases will accept those parameters and run according to that accepted parameters. It will run the test cases and it will tell us whether that test cases will give pass and fail according to that parameter that we have passing to that test cases, right? So how we can write these type of test cases in the JUnit, we will be seeing in this video. So let's get started. I will go inside my IntelliJ IDEA, and over here I have set up one small example for you, which is the traditional or the not traditional. We have up till now what we have seen. I have arranged that example over here. Over here you can see we have student score calculator class, which is the Java class. Okay, and inside which calculate sat score is there, and which is accepting two parameter math score and the literacy score, right? So we are calculating the SAT score of that user based on the score that he or she is getting inside the math score and the literacy score, right? So if the math score is less than 0 or greater than 100, that means that score is invalid, and then in that case we can set the SAT score as -1 and tell the user that please give the valid input or that correct input, right? So same goes with the literacy score. If the literacy score is less than 0 or greater than 100, then in that case we can also set the SAT score as -1 because that is not the valid score, right? So if none of these cases getting evaluated as true, then in that case we know we have valid math score and the literacy score. Then we can calculate the SAT score, and the formula to calculate the SAT score is multiplying the math score and the literacy score. Okay. Okay, and so this is how we are calculating the SAT score. So now we have to test this calculate SAT score method. So we are writing this student score calculator test.java class, inside which we have written these 1 2 3 4 5 6 7 different test cases. And you can see what we are doing here is, first we are passing 50-50. That means 50 is my math score and 50 is my literacy score. And then what is the formula? We are doing multiplication, then 50 into 50 we get 2500. Then in that case this test case will get passed. Now here we are passing math score as -1 and literacy score as 50. Now we can see literacy score is valid because the literacy score lies between 1 to 100, right? So but the math score is less than 0. That means this if condition will evaluate as true, and then in that case our SAT score will be set to -1. And here over here expected output is -1, and we also get the -1 over here. So you can see what are all the condition in where we can get the -1 as a SAT score, right? So if the math score is less than 0 or the greater than 100, and the literacy score is less than 0 or the greater than 100, right? So we have written those four, 1 2 3 four test cases, and these two remaining test cases we have written for the what if both are negative, right? So over here you can see we have one method both negative. So if both numbers are negative, and we have another condition where both the numbers are high, that means above 100, right? So these many test cases that we have written over here just to test the one method. So we can what we can do is we can pass the parameters, right? So there are nothing different from these methods, just we are changing the parameters that we are passing to that methods, right? So we will create one more Java class where we can see how we can reduce this number of lines of codes by writing just one method which accept the parameters from the user, not from user. We will be giving one object or array to that class, and that class will accept that um object array and process our test cases. Before that, we will just go ahead and see whether these test cases will run or not. This is our previous way that we have seen so far in this series. Okay, so you can see all the test cases get passed. 7 out of 7 test cases get passed, and now we will go ahead and see how we can create a parameterized test cases so that we can reduce this many number of lines of codes, and we just write one method and our job will be done. Okay, Java class. Let me call it as student params test. Okay, so inside this, okay, so now we are, since we are using the parameterized, so we have to tell this class or this class as with the annotation as run with JUnit 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 pa- para params runner JUnit params runner dot class. Okay, so we are searching for dependencies. Just wait a minute. Let it be done. Okay, so I guess yeah, so over here inside this class, what we can do is we can just wait a minute. Why I'm getting this error, I will just rectify this error. Okay, so the error that we are getting because we have not added the dependency for the JUnit params runner. So we have added the dependencies over here. Over here you can see we have added two more dependencies, JUnit params and JUnit params, and both are different because we are the scope of both of these dependencies are different because one scope is test and one scope is for compile, right? So now we can go ahead and just uh, do our rest of the things that we want to do. Over here what we'll be doing is we'll be creating one test case. Okay, so to create a test case, we know add test is the annotation that we give, and over here since it is a parameterized, so we will write parameters, and for now we will just write method is equals to let me call it as test values. Okay, so test values is our method. Don't worry, I'll be explaining all this stuff in just give me few minutes. Just I will write public void our method name should be anything test now, and this will accept the three parameters. One is math score, one is literary literacy score. So just I'm going to copy this one from here and just paste it over here, and after that third parameter is expected score, right? So expected score that we also want to pass. Okay, so over here we can create the object of the student score calculator class. Score is equals to new student score calculator, and now you can use that object to call that calculate sat score, and after to that we can pass the math score and the literacy score that we are getting from this parameterized method, and now we can use the assert equals. Okay, so we need a assert equals, and to this we can pass the expected score, and the actual score would be this sc dot get sat score that we have written over here. Get sat score, it will pass the or return the sat score to us. Okay, so this is how you can write. Now we just have to implement this method where we are passing this all these three parameters in using one object. So we can what we can do is we can create one method private static, and this since this will hold the objects, right? So object test values, and all right, and over here inside this we will just return the object, return a new object, right? And this object will contain the all the objects that we're gonna pass to it. Okay, so right object, and here we can pass all these parameters that we are passing through this method, right? 50 50 to 2500. Okay, so we will pass 50 comma 50 comma 2500. So this is our first value that we are passing, and similarly we will pass all these value that we have written over here for the 7 different test cases, right? So for the second one we can what we can do is we can write like this. Now we can pass minus 10 50 minus 1 minus 10 50, and then it should be minus 1 because since one value is less than 0, right? So again we can replicate that, and we will write 50 minus 1, and in this case also you should get -1. And now for the fourth one we will pass all -1. And now for the fifth one we have 150, 50 minus 1, 150, 50 minus 1. In here 50, 150 minus 1, 50, 150 minus 1, 150, 150 minus 1, 150, 150 minus 1. We'll give all 0. This also we will test. Okay. And last one where both are high, just like 100, 100, and now here also we should get 10,000 because 100 into 100 is 10,000. Okay, so this is how we will create those objects, and we will pass this method values to this test values, right? So we just checking. Okay, method is equal to test values, right? So we will go ahead and call this just to check whether everything is working fine, and our all test cases should get passed. Yeah, over here you can see 9 out of 9 test cases will get passed. How many we have written? 1 2 3 4 5 6 7 8 9. See, 9 out of 9 test cases passed. So what we have learned in this video is how we can pass the parameters to the test case, and according to that parameters our test cases should run, and we will get the desired output. We will see here for each test cases what is the output and how we are getting the output, right? So instead of writing these many 60 line of codes, we can do that in 30 line of code. So we are just half we have cut down the half of the line of the codes just to by passing the parameters to that method, right? So this is how we can create the parameterized test cases in JUnit. So in this video we will be talking about exception testing in JUnit. Okay, so how we can handle our exceptions in JUnit while testing our test cases. And now for this video prerequisite, we should know what is exception handling in Java, and what are all different classes that are involved in exception handling in Java. Okay, so if you do not know anything about exception handling in Java, so I would suggest you to go ahead and watch one video on exception handling in Java and gain some knowledge about exception handling, and then come back here and continue this video. Okay, so to explain this exception testing in JUnit, I have one example over here. You can see we have cashier.java class, and this cashier.java class has one method which is validate transaction method, which accept the currency and the amount that we are passing. Okay, so the currency for this example, I have set the currency as euro and GBP. So these are the two currencies that we are passing, and this currency we are passing as arrays as list. So we are passing this list to this currency, and we have one amount that we are passing, and we have two methods to validate those currency and the amount, right? So if the currency that we are passing to this method is not from these two options that we are passing as a list, then in that case that we will throw one illegal argument exception. So again, as I told you, this throw what is illegal argument exception, you will get to know only if you know the concept of exception handling. Okay, so we will throw this one illegal argument exception, and we will tell the user that this currency, the currency that that user is trying to pass this method, is not within the accepted currencies list. Okay, so we are for example, user is trying to pass the USD, that is US dollar currency, then in that case that currency is not accepted by our code, then in that case we will show illegal argument exception. Okay, so similarly we have amount is valid, this method, and both the method are boolean, so they will return true only if the conditions that are written inside them is getting satisfied. Okay, so if the amount is less than 0, then in that case we don't want that one, that argument as well. So in that case we have written one invalid transaction amount exception, and this exception is defined over here. We have created one more exception class. So this is the exception class in Java. You can see the symbol is also different for the exception class. Over here we have written this exception, and we are calling the super, that means we are calling the parent class method. Okay, so over here we have saying that transaction amount must be greater than 0, and if the amount is greater than 0, then in that case we will just simply return true. Okay, so over here we have written the if condition, and we have called those two methods. If both the methods are true, then and then only we will return the amount. If that is not the case, then in that case we will return -1, telling that there is one condition where currency is not accepted or the amount is greater than sorry, the smaller than 0. Okay, so we will go ahead and create one cashier test Java class, and over here inside this Java class we will just first create our main cashier test class. Okay, and now inside this we will write our test cases. So for defining the test cases, we know we have to write add test, and okay, so after that we will write public void. So public void, so we will be writing two methods. One is to check the currency, and one is to check the amount. Okay, so we will be writing two. So just let me name it as validate currency, and in this method what I will be doing is we will be writing cashier dot validate transaction, and we will be passing the currency which is not supported, right? So USD is not supported because we have not written USD inside this list, right? So it should give me this test case should not get passed, and amount is 10. So okay, so this is what we will be writing, and again we will be writing one more test case at test, sorry, at test, and below this we will be writing public void validate validate the amount, and inside this we will be writing cashier dot validate transaction. And now since we are validating the amount, I will give the currency that is supported. So we will be writing EUR as a currency, but the amount that is not supported will be giving -10, which is not supported amount. Okay, so since this is an integer, I should get rid of this double quoted. Okay, so over here if I run this cashier test case, so I should get errors. Our test cases should not get passed. Okay, so see, transaction amount must be greater than 0 because validate transaction, the transaction amount is since this exception is thrown, and again we are getting one more error that currency USD is not within the accepted currency list. We are getting this, we are throwing this exception. Okay, so to handle this exception, what we can do is in JUnit we will just pass here expected is equals to runtime exception dot class, and similarly we will be passing this also. Okay, and now if I go ahead and just click on run, now the both test cases will get passed. Yeah, you can see both test cases are getting passed because what we are telling this test case is that my expected output should be a runtime exception, and this call over to this validated transaction is actually creating a runtime exception because this currency is not getting accepted, and this one also creating a runtime exception because the amount that we are entering over here is not accepted by our method, and which will create a runtime exception. Okay, so what we are doing is we are telling that this class extends a runtime exception, so we can write the runtime exception over here as well. So this class, the expected output and the output that we are getting from this method call and also from here, both are runtime exception. That's why our test cases is getting passed. Okay, so this is how you can handle the runtime exception, and we have seen how we can check the runtime exception in Java. So today in this video we'll be talking about the best practices that you can follow, or the tips and tricks that you can follow to write your test cases while using JUnit. Okay, so no doubt writing a good JUnit test cases is a rare skill, just like writing a good code, right? So a good code, a well thought and well written JUnit test case can prevent the several production issues during the initial development or the later maintenance in the Java application. Okay, so it can also reduce your cost of development as well. So, okay, so in this video we'll be talking about the best practices. So let's get started. So our very first best practices is always test core methods. Okay, what it means, it's not practically possible to get 100% code coverage, so you don't aim to write the unit tests for each method and trial operation. Instead, write unit test cases for a method that is likely to have bugs during the maintenance, right. So always test core methods and core classes which are used heavily by different parts of their program. Okay, so just don't go for testing all of your methods that you are written inside your code. Just test the core methods you are using always, or more number of times, so that you can get a good uh, system that you are trying to build. Okay, so second one is run the JUnit test case as a part of build process. Okay, so you should integrate the JUnit tests with your build script, so that with every compile your test runs automatically. Like Maven, ANT are the two most popular build technologies for the Java application, provides a support for the JUnit tests, right? So if you watch our previous tutorial series for JUnit, so there also we are using Maven, right? So here you can see we have pom.xml file where we are adding our dependencies. So the builds tools like Maven and ANT are the good that we can use, so that every time our build get executed, that time our test cases are also getting executed, right? So this is a very good practice. Third one is always test for boundary conditions. Okay, so develop the test cases based on uses and the boundary conditions. This is my favorite JUnit practice as well, because mostly asked as an interview question also on JUnit as well. For example, if we have asked to write a function to replace all the occurrences of the character from a string, right? So this is our example. So how will you write a test case for that? Okay, to my surprise, many Java programs start up focusing on the JUnit test syntax like setup and tear down. Okay, so even before thinking of actual test case scenario like testing for an empty text or an empty character in that string, test for an character which is not a string inside the string. Okay, so these are just a few test cases that I can think of, but the idea is to focus on what to test, right? So and how to test. Most IDE like Eclipse and NetBeans will take care of that, and IntelliJ IDEA is also taking care of that one as well. Okay, so the next is align test with business requirements. Okay, so make sure your JUnit test is aligned to your business requirement specified in the BRD or the business requirement document. Okay, so always try to write your test cases with according to your BRD, that is business requirement document, because ultimate goal is to reach that requirement and build a product that will gain you more uh, income source from that project, right? So test for non-functional requirements. Okay, so write a test for a non-functional requirement as well while writing a thread safe class. Okay, it's important to write the test that try to break the thread safety. Okay, so test for ordering. Okay, if a function, I will give you an example. If a function or a method depends on upon the order of events, then make sure your JUnit test covers ordering requirement, and my take is to test both side of the coin, means with the correct ordering method should produce a correct result, and with the incorrect ordering it should throws an exception, because like suppose we have two methods, one and two method, first and second method, and for the execution of the second method, the first method need to be get executed, right? So what we can do is we can consider two scenarios, where first scenario where our first method will get executed first, and then second method will execute it secondly. Okay, so this will give us true feedback, or the test cases will get passed. But in the second scenario, we will try to run the second method first, and then we will run the first method, and but here it should throws an exception telling that the first method should get executed first, then and then only the second method will be executed. So this is how you can test for the ordering. And the last one is use at ignore annotations. Okay, one idea which helps me while writing a unit test is to create a dummy test while working with the requirement, because that's the best time you remember requirements having a test case with a comment that describe a intent of the test lets you to implement it later, or just put at ignore if you don't have time to implement the test. And using JUnit for annotation, you can do that by using the @ignore annotation. So this is also a great best practices that you can follow while writing your JUnit test cases. Okay, so these are some best practices that you can follow while writing your JUnit test cases. So today in this video we'll be learning about annotations in JUnit, right? So in our previous video as well as previous tutorial series, as you might have seen that we have writing this add test so many times before creating the method that is test case. So what actually does it means writing the add test, and what are all different annotations that are there inside JUnit? So we'll be looking in one by one in this video. Okay, so first annotation is add before class. So this annotation is used to initialize an object that we use in our running test cases. Whenever we initialize any object in before class method, it would be invoked only once. Okay, so this add before class, the method that you are writing after this add before class annotation, this would be invoked only and only once. The primary purpose of add before class JUnit annotation is to execute some statements before all the test cases mentioned in the script. Okay, so the this is the add before class, so we can use that. So add before annotations. Okay, so this annotation is used whenever we want to initialize any object for the time the method is being called. Okay, so suppose we are having 5 test cases, right? So the before method will be called before each test method for the 5 times. So it would be invoked every time the test cases is executed. This annotation is usually used for the setting up the test environment. So if you want to set up the test environment, you can use the add before an annotation, so that each time your test cases will be executed, before that this method will get executed and your environment will get set up. Okay, so next is add test. So this annotation tells the JUnit that the public void method to which it is attached can be run as a test case. This annotation includes the test method for an application that you want to test. A single automated automation test scripts may comprise numerous test methods in it. Okay, so this is the use of the add test annotation. You can see over here, here as well. We have written this add test, and after that we have written a method, which is our test case, right? So this is the use of the add test annotation in JUnit. So okay, so the next is add after. Whatever we initialize in add before annotation method, that initialization should be released in add after annotation method. Okay, so this annotation is executed every time after each test method. The primary purpose of the add after annotation is to tear down. Tear down is a process of deleting the temporary data. Tear down can also be used to define a default values or to wipe the slate clean to test the environment. Okay, so we have seen add before, where we are setting up the our environment and we are initializing some variables. Okay, so those variables we have to tear down. Okay, so for that we can use the add after. So we can use that add after, and we can define one method where we are cleaning up our environment and the variable that we have created for the testing purposes in that test method, right? So again we have after class. Whatever we initialize in add before class annotation method, that initialization should be released in add after class annotation method. So this annotation is executed once, but it will be executed after all the test cases has been finished executing. Okay, so it is kind of similar like add after. Add before class, we have add before class where we are setting up our class, and here add after class we are tearing down our all those resources that we are assigned or created to testing purposes, right? So we have at ignore. This annotation tells the JUnit that this method shall not be executed in the scenarios where our code module is not ready. In a particular test cases, we can temporarily put that code module in at ignore annotation method to avoid the test case failure. Native There is a catch. Native JUnit 4 offers powerful reporting to help you realize the count of the tests that were ignored, along with the count of tests that run and count of the tests that failed. Okay, so this is the at ignore annotation, which is pretty useful where your code is not ready and you are writing that test cases. Okay, so these are the some important JUnit annotations that you need to understand, and you can use that annotation to write your test cases according to your uses. Okay, so thank you for watching this video, and I will see you in the next one.